Ever hear of a technology that was so brilliant, so advanced, that it completely defined an era of aviation, only to, well, vanish? That's exactly what we're talking about today. We're diving into one of the coolest, most complicated ideas to ever get off the ground, the swing wing.
Okay, take a look at this. You're seeing two jets that look totally different, right? One's got its wings spread wide like a classic fighter. The other looks like a high-speed dart. But here's the crazy part. They're the exact same plane. This picture captures the same aircraft just moments apart. And that incredible transformation? That's what this is all about.
So, that ability to literally change shape in midair gets right to the heart of a huge problem for jet designers. What if you could build one single aircraft that was perfect for everything? Perfect for slow-speed flight, but also perfect for superspeed. I mean, how do you design a plane that can take off from a short runway, fly slow and steady, and smash the sound barrier without tearing itself to pieces? For a long, long time, that just seemed impossible. You had to make a compromise.
All right, so to really get why the solution was so genius, we gotta understand the problem they were facing. And it all boils down to how wings work at really, really different speeds. So here's the big trade-off. On one hand, you've got straight wings. These are awesome for flying slow. They give you a ton of lift, which is exactly what you want for taking off and landing easily. But get them near the speed of sound, and they turn into giant air brakes. So much drag. Now, on the other hand, you have swept wings. These are built for speed. They're essential for going supersonic. They just slice right through the air. The problem? They're awful at low speeds. They need super long runways to get going. So for decades, designers had to pick their poison. You got one or you got the other.
But what if you didn't have to choose? What if you could get the best of both worlds? Well, that question led to one of the most incredible, most ambitious ideas in the history of flight.
And here it is, the solution, the variable sweep wing. You probably know it as the swing wing. And the idea, when you boil it down, is so simple it's almost elegant, but the execution is just mind-blowingly ambitious. The idea? Just build a plane that can literally change the shape of its wings in the middle of a flight.
Okay, so let's see how this works in the real world. For takeoff or landing or just cruising around at low speed, the wings are spread way out, almost straight, just like you see on this B-1 Lancer here. This shape gives the plane the most lift, makes it super stable, perfect for the slow stuff.
But then, when the pilot needs to hit the gas, those wings swing all the way back, sometimes in this really dramatic motion, into this super swept back position. The whole plane just transforms into this sleek, streamlined dart. It's now perfectly shaped to blast through the sound barrier. It was, no joke, the ultimate aerodynamic chameleon.
Now, this idea didn't just pop up out of thin air. The roots go back to late World War II, with German designs like the Messerschmitt P1101. Now, its wings could be adjusted, but only on the ground. After the war, the Americans got their hands on it and built the Bell X-5, and that was the first plane that could actually move its wings in flight. And you had brilliant engineers like Barnes Wallis in Britain who were dreaming up even crazier wing-controlled aircraft. The idea was definitely in the air.
So all those early experiments, they really set the stage for a technological explosion. Because once we hit the peak of the Cold War, the swing wing wasn't just some weird experiment anymore. No, this was seen as the future of military air power.
And man, did this technology take off fast. It really kicks off with the F-111 in 1964, and then for the next 10 years, boom, it's an absolute explosion. The US, the Soviet Union, a whole group of European countries, everybody had to have a major swing wing program. It was a flat-out technological arms race.
And you just cannot talk about swing wings without talking about the most famous one of all, the F-14 Tomcat. This plane was an absolute icon. It took the whole concept and cranked it up to 11. What was so revolutionary? Well, for the first time, it had an onboard computer that would automatically move the wings to the perfect position for whatever the plane was doing. That was a huge step, kind of like a sneak peek of the digital flight controls that are standard today.
And hey, this wasn't just an American thing, not at all. Over in Europe, you had the Panavia Tornado. This was a joint project between the UK, Germany, and Italy, and it became the absolute workhorse for a bunch of European air forces. It could do anything, strike missions, interceptions, and it really proved just how versatile this swing wing design could be.
Meanwhile, on the other side of the Iron Curtain, the Soviet Union was all in. They were building swing wing jets like the MiG-23 fighter and this bomber here, the Sukhoi Su-24. It just goes to show you, at that point in time, if you wanted to be seen as a top-tier modern Air Force, you had to have swing wings.
So okay, the swing wing is this amazing idea. It gives you performance that nothing else can touch. But behind that super elegant solution, there was a massive hidden problem.
And that problem, in one word, was complexity. I mean, look at these jets from the outside. They are sleek, they are powerful, but then you peel back that outer layer and you see what's really going on inside. This absolutely massive, unbelievably complex, and heavy mechanism to make the wings pivot. This right here, this was the swing wing's Achilles heel.
And that complexity? It brought a whole host of problems. For starters, all that machinery weighed a ton, which started to cancel out the performance benefits you were getting in the first place. These planes were also just insanely expensive to build and a total nightmare for the ground crews to maintain. And to top it all off, every time the wings moved, the plane's whole center of lift would shift, which meant you needed even more complicated systems just to keep the thing stable and flying straight. It was a snowball of complexity.
For about 2 decades, all of those drawbacks were just the price you paid to get that incredible performance. But then, something new came along. Something that would make this brilliant, magnificent mechanical solution basically obsolete, almost overnight.
Which brings us to the big question, right? If these things were so capable, if they really were the best of both worlds, then why don't we see them anymore? Why don't modern jets like the F-22 or the F-35 have them? Seriously, where did they all go?
The answer wasn't a better piece of machinery. It wasn't a stronger hinge or a more powerful motor. Nope. The answer was the microchip.
This is the tech that made the swing wing obsolete, fly-by-wire. See, instead of relying on heavy mechanics to change the shape of the wing, fly-by-wire systems use computers. And these computers make thousands of tiny adjustments to the plane's control surfaces every single second. This lets designers do something that sounds crazy. They can build planes that are naturally unstable. Think of it like trying to balance a broomstick on your finger. It wants to fall, but you can make tiny adjustments to keep it upright. The instability is what makes these new planes incredibly agile, and the computers do all the work of keeping them stable. And just like that, you could get amazing performance at both high and low speeds from a simple fixed wing, all without the weight, the cost, and the maintenance nightmare of that giant pivot mechanism.
And this plane right here, the massive Russian Tu-160 bomber, really seemed like it was going to be the final word on the subject. It first flew back in the 80s, and it is the biggest, heaviest swing-wing aircraft ever built. It was like this magnificent monument to a technology that was on its way out. And for decades, it looked like it would be the very last of its kind.
But then, a twist. Russia needed to update its bomber fleet, and so they did something nobody expected. They restarted the Tu-160 production line. So after almost 30 years of no one building a new swing-wing jet anywhere in the world, suddenly they were rolling off the assembly line again.
And that brings us to a really interesting final thought. The swing wing was this incredible mechanical masterpiece that was basically killed off by a digital solution. But its recent comeback, even if it is just for one specific aircraft, it makes you wonder, doesn't it? In a world that's so focused on software, on AI, and digital fixes for everything, is there still a place for brilliant, complicated, purely mechanical solutions? Are there still some problems that are best solved with a piece of heavy, magnificent machinery?